Dear students, in this video we will learn about the normal distribution. Let us suppose we have a table, an ordinary table with class interval, mid value, frequency and with the probabilities. Usually we get tables with class interval, mid value and frequencies, but you can find out the probabilities from the given frequency distribution as well. Now when we plot the frequencies along the y-axis, here the frequencies and the class interval or the mid values on the x-axis, will get a bar diagram or a histogram like this. Now if we plot the probabilities for the class interval, respective class intervals, and we join the probabilities with a smooth curve, we will get a curve like this. Now this curve has some specific characteristics. If you compare the histograms for the left hand and right hand side histograms of this middle one, you will see from the left hand side you have this histogram and the right side we have this one, and these are similar. The height is same, the area is same, so probabilities and frequencies are same. Likewise, the consecutive histograms from the to the left side of this middle and the right side of this middle histograms are almost similar. If you carefully look at this diagram, if we draw a line perpendicular to the x-axis at the middle of this diagram, the left hand side portion is exactly similar to the right hand side portion. This kind of diagrams are called symmetrical diagram. The curve is called a symmetrical curve. Now let us see the definition of normal distribution. It says a random variable x is said to follow a normal distribution with parameters mu and sigma square if its probability density function is given by this probability law. Now, if we have a set of data, we can easily find out the mean, which is denoted by mu for the population and x bar for the sample. Again, you can find out the variance from the same set of data, which is denoted by sigma square for the population and small s square for the sample. Now let us see the function of this probability density function. Since x is a continuous random variable, so we'll call it probability density function. That probability density function, that means the probabilities of x, are given by this formula 1 by sigma, which is the standard deviation square root of the variance under root twice pi. Pi is a constant 3.141596, the standard value we can take. Then exponential of minus half x minus mu by sigma square. Or otherwise we can write it like this: sigma 1 by root over twice pi, sigma will be in the denominator, exponential, can I write 1 by sigma root over twice pi e to the power minus half x minus mu by sigma whole square. This gives the probabilities at different points of x for the normal distribution. Some remarks on normal distribution. Number 1. A random variable x is said to follow a normal distribution with parameters mu, which is mean, and sigma square. The variance is written as x follows normal distribution with mean mu and variance sigma square. The meaning is that X is a continuous random variable which follows normal distribution with mean mu, that is the mean of X is mu and sigma square. Sigma square is the variance of X. Second one, if X is a normal random variable with mean mu and variance sigma square, then the transformation z equal to x minus mu by sigma is called the standard normal variate with mean 0 and variance 1. And we write z follows normal with mean 0 and variance 1. Now our original normal distribution function was f of x equal to 1 by sigma root over twice pi e to the power minus half x minus mu by sigma whole square. Now in place of x minus mu by sigma, if we put z, a new variable z, then the function will become f of z, or we can write down any other functional value like phi, because already we have taken f for the normal distribution. Let us take phi of z, which is equal to 1 by sigma root over twice pi, sorry, sigma 1 by root over twice pi e to the power minus half z square. Since original function this value was x minus mu by sigma, replace x minus mu by sigma by z. So new variable with the new variable z, the function becomes 1 by root over twice pi minus half z square, which is called the standard normal distribution, and z is called the standard normal variate. Now some of the characteristics we'll discuss. Chief characteristics of the normal distribution and normal probability curve. The normal probability curve with mean mu and standard deviation sigma is given by the equation. We have already learned this equation, where this is the PDF of x, and x follows normal distribution with mean mu and variance sigma square. Now if you plot the curve on a graph paper, it will be like this. We have already discussed that it is a symmetrical curve. That means in the middle, if we divide it, the left hand portion is exactly similar to the right hand portion. So the curve is bell shaped and symmetrical about the line x equal to mu. Now it is this middle point where the median lies. The median divides the entire distribution into equal parts. This is the median point because half of the distribution or the data lies on the left hand side of this middle point or the median, and half of the data lies on the right hand side of the median. And this point is median. But one of the characteristics of the normal distribution is that the same point in a median point, mean and mode also lie. So this point is median, which divides the entire distribution into two equal parts, but the same point is mean and the same point is mode, because at the point mode the probability or the frequency is maximum. If you see this point, just immediately above this point, this is the peak point of the curve. This is the mode because the maximum probability or frequency lies exactly above this point. The mean, median, mode of the normal distribution coincides. That means they are the same. Mean, median, mode of normal distribution are same. Number 3, the property number 3. As x increases numerically, fx increases rapidly. The maximum probability occurring at a point x equal to mu and given by this probability maximum 1 by sigma root over twice pi. If you look at the curve, this way x will increase, and on the y-axis f of x will increase. So x increases numerically. X will increase this side, then y also, fx also will increase, and it will attain its maximum point. Again, it will come down to a minimum point. Now, the maximum value of x probability at this point is 1 by sigma root over twice pi, which is given by this y-axis. Beta 1 equal to 0 and beta 2 equal to 3. Beta 1 is the skewness of a distribution or a curve. Since normal distribution curve is a symmetrical curve, it is neither positively skewed nor negatively skewed. So it's a symmetrical curve. For that reason, beta 1 equal to 0. And beta 3 equal to 3. That gives the kurtosis of a curve. So if it is a very big, if the curve is very big curve, it is called leptokurtic curve. If it is a very flat curve, called platykurtic. And if the curve is in between this leptokurtic and platokurtic, this is called a normal curve. Now for a normal distribution, the curve is neither a leptokurtic nor a platykurtic. It is a normal curve. So for normal distribution, you can say that beta 2 value is 3. If beta 2 equal to 3, you can say that the curve is a normal curve. Otherwise, if it is peaked, beta 2 value is greater than 3, it is a leptokurtic. If beta 2 value is smaller than 3, it is a platykurtic curve. Now the even order moments are given by this formula. Even order moments means the mu are called the moments. Mu1, mu2, mu3, mu1 dash, mu2 dash, these are called the row moments, and mu1, mu2, these are called the central moments. Now for a normal distribution curve, the odd order moments are 0. That means odd order moments are mu1, which is always 0, of course. Then mu3, mu5, these are called the odd order moments. So these moments are all 0. Now for the even order moments, means even order moments are mu2, mu4, etc. mu6. Mu2 is nothing but the sigma square, the variance of a distribution. Then comes the mu4, mu6, etc. Now any of the moments which is denoted by mu twice r, where r we can put r equal to 1, 2, 3, 4. If r equal to 1, it is 2. If it is r is 2, then it is 4. If r is 3, then it will be mu 4, etc. These moments are given by this formula 1 into 3 into 5 up to 2r minus 1 into sigma to the power twice r. This is the formula for to find out the even order moments. Otherwise, the odd order moments all are 0. Next, since fx being the probability can never be negative, no portion of the curve lies below the x-axis. If you look at the curve, the entire curve is above the x-axis. If it is x-axis, no portion of the curve comes below the x-axis, because probability is probability curve. So probability never be negative. So if this point is 0, then all the probabilities will lie above 0. 0, either 0 or more than 0. It cannot be negative. Linear combination of independent normal variance is also a normal variance. Say suppose we have some normal distribution variant, that means it follows normal distribution with some mu1 and variance sigma 1 square. Another variable x2 which also follows normal distribution with mean mu2 and variance sigma 2 square, and so on. Ultimately, the linear combination is nothing but say a times of x1 plus b times of x2 plus etc. We may have more than two normal variables. This addition, let us suppose this is denoted by x, which again follow the normal distribution with mean sum mean mu and variance sigma square. That means if x1 x2 are different normal variables with different means and variances, their linear combination is also a normal variable with some mean and some variance. X-axis is the x-axis is the asymptote to the curve. That means if we draw the curve, the normal curve will reach will approximately go to the x-axis. It will go very near to the x-axis, but it will never touch. So this is called the asymptotic property of this curve. So for normal distribution, the curve is a asymptote to the x-axis. It will never touch. It will go very nearer. The difference between the curve and the x-axis may be infinitesimally small, but it will never touch the x-axis. The points of inflection of the curve are given by x equal to mu plus minus sigma. As we know, the middle point is mu. We can define the distance from mu as 1 sigma mu plus 1 sigma. This point is mu plus 1 time of sigma. This point is mu plus 2 times of sigma, etc. So where mu is the mean and sigma is the variance, mu will fall always at the middle point. Sigma times this is the distance from mean, the middle point, mu plus this point is mu plus sigma, mu plus sigma. And likewise on the left hand side it will be mu minus sigma. This point will be mu minus 2 times of sigma, and so on. 3 sigma this way. The point of inflection means a curve will, the normal curve increases from the left hand side and it will go on increasing. Now it will start to decline so that it reaches a peak point and again it will go down. Now where it starts to move little downward, it is now on the left hand part side it is going upward, and reaching at this point it will started leaning downwards. So this point is called the point of inflection, and this point of inflection for the normal curve is, for the left hand side it is mu minus sigma. Again on the right hand side, after reaching a peak point it will go on declining, and at this point it will be a little slower, the declination. So this point is mu plus sigma. So point of inflection, these 2 points are called the points of inflection. And these 2 points lies on the right hand side it is mu plus sigma, and on the left hand side it is mu minus sigma. So mean deviation about mean is 2 by pi sigma equal to 4 by 5 times of sigma approximately. Quartile deviation is denoted by q3 minus q1 divided by 2, which is 2 by 3 times of sigma. Now there is an important relationship between quartile deviation, mean deviation and standard deviation for normal distribution. So quartile deviation is to mean deviation is to standard deviation, which is approximately equal to 10 is to 12 is to 15. Next is area property of normal distribution. So if you look at this diagram, for any distribution the total probability is always 1. So we can say that the total probability under this curve is equal to 1. And this we call the area of the curve, area under the curve, area between x-axis and the curve, which gives the probability of the distribution. And this one is the middle point, which is mu, because we know that always mean, median and mode lies at the middle point. And we can find out the distance from this middle point to sigma, that is mu plus sigma. this point is mu plus 2 sigma, this point is mu plus 3 sigma, and on the left hand side this point is mu minus sigma, the second point is mu minus 2 times of sigma, third point is mu minus 3 times of sigma, and infinity the lowest point, and plus infinity is the highest point. So according to the normal probability curve, if we see the area between this mu minus sigma, this point mu plus sigma, the area, this area covers almost 68.26% of the total area. The area between mu minus sigma to mu plus sigma is 68.26. If we extend further, that means if we take the area from minus mu minus 2 sigma to mu plus 2 sigma, this area covers 95.44% of the total area. And if we take from the minus mu minus 3 sigma to mu plus 3 sigma, almost all, which covers 99.73%. That is almost all. Less than 1% area are left from minus infinity to minus mu minus 3 sigma and mu plus 3 sigma to infinity. Area is less than 1%. So the entire area is covered. Almost entire area is covered from mu minus 3 sigma to mu plus 3 sigma, which is equal to 99.73%. Again, this is in terms of mu and sigma. When the random variable x follows normal distribution with mean mu and variance sigma square. Again, we have learned that we can transform this variable to z, that is transformation x minus mu to x minus mu by sigma, and this new random variable z follows same normal distribution but with mean 0 and variance 1. If any normal distribution with mean mu and variance sigma square is converted to new variable z, which is x minus mu by sigma, which follows a normal distribution with mean 0 and variance 1. Now in this case the value will be little different, same curve, but in this case since the mean is 0, so middle point will be 0, and the distance from the mean to the left hand side and to the right hand side we can write as, say, previously it was mu plus sigma, so sigma is 1, so it is value will be 1. This is 2 and this point is 3, because originally it was mu plus, suppose this point is sigma, now mu is 0, mean is 0 plus sigma is 1, so it will be equal to 1. Likewise on the left hand side this point is minus 1, this point is minus 2, and this point will be minus 3. That means originally it was mu minus sigma, so mu is 0, sigma is minus 1, it will be equal to minus 1. So for the new variable z, the values are 1, 2 and 3. For the old variable it is mu plus sigma, mu plus 2 sigma, mu plus 3 sigma, but the area will be same. The area for z is from minus 1 to plus 1 is, say, z equal to plus minus 1, which area is again 68.26%. If it is 2 plus minus 2, 95.44%, and if it is 3, then it is 99.27%. Area will be same, but the values of mu and sigma will be different. Thank you for watching.